afternoon, everyone, and welcome to WASA Distance Education. This is MBF3C, and my name is Marvin. I'll be the instructor for this course. As you can see me on screen right now, I'm going to switch and share my screen, but I don't see where to do that at the moment. Okay, let me just maximize this and share screen. So I will share my screen with you and share. And going through that. So Jonathan, can you verify that? Oops, that's not what I want. I want my Microsoft Word. Okay, so Jonathan, can you see my study guide on the screen right now? Or are you still seeing me? And share. I'm assuming that you're seeing what I'm seeing, which is the study guide that was sent along with the course content. Uh, but I'm seeing me up in the right-hand corner, but I'm assuming you are seeing my screen. Jonathan, can you verify that, please? Can you verify that my screen is visible and you are recording? Okay, awesome. Thank you. Okay, so we'll get started. Again, my name is Marvin. This is Foundations for College Mathematics, grade 11. So you would have completed grade 9 and grade 10 math by now, or maybe you've done the PLAR. So this course is going to last it's going to last 9 weeks, 4 classes per week, Monday to Thursday. I've uh, attached my email address, which you can see on screen. It's marvin.osmond@nnecschools.org. Feel free to email me at any point. I do not have an office at WASA. I do have a cell phone number that I've listed there. It's 1-8077-382-031. You can call me or text me on that number, as I do not have an office in Wausau. So that's probably going to be your best bet if you want to talk to me. If you want to email me, then use the email address that you see there on the screen. So college mathematics, well, get you ready or start to get you ready if you want to go to college when you graduate high school. So that's what this course is intended to do. The outline, you can read through that. I won't read it to you, but it does go through some of the things that you're going to be doing. And the important part is the materials that you're going to need to be successful in the course. So you're going to need the units. There are 4 units, and I'll get into those a bit later. Uh, they will be at the Learning Center, so you can talk to your DEC. You can probably get a digital copy or a printed copy. So you'll need that to start. You're also going to need a scientific calculator. There are online ones that you can use, but if you have one of your own that you're used to using, then use it. Or you can check with your DEC to see if there are ones in the Learning Center that you can use as well. It's best that you stick with one. So find a calculator that you like and then stick with it. You are going to need one that is a scientific one, so it does more than adding, subtracting, multiplying, and dividing. So trigonometry and things like that. Um, you're going to need paper as well, and that's probably in the Learning Center, and graph paper that you'll need a bit later in the course. Actually, you're going to need it right in the first unit. Ruler and writing utensil. So for me, my preference is you complete all of your key questions that you're going to send to me to be graded using a pencil. And that way, if you make a mistake, you can easily erase it and make the correction without having to use whiteout if you're using a pen, for example. So pencil is preferred. Um, the best way um, to get through the course successfully is try to stay on top of the course and try to do the lessons in order that we are doing them. So today we're going to do we'll get started on the first unit and the first lesson, and then at the end of today, you should try to complete the support questions and key questions that deal with today's topic. And that's the best way to be successful. Classes only run 4 days a week, so Monday to Thursday. Friday is a catch-up day, so it's a time for you to review material and get caught up if you've fallen behind. The further you fall behind, the harder it is to get caught up. Uh, I'm available 7 days a week. I'll even take calls on the weekends. I'll take calls up to 10 p.m. at night. I'm usually up early in the morning by 7 or 8. So you've got lots of time to contact me. I do have another job. This is just I'm doing this part-time, so I may be busy during the day at times, so it might be a good idea to shoot me a text when you want to chat, and then we can arrange a time that we both are available and we can sit down. We can Zoom if you want, so I can show you my screen and help you through any problems you might be having. The lessons are broken down. You'll see descriptions of content, and then you're going to see support questions and key questions. So support questions are practice questions. They're ones that will help you get ready for the key questions. So they do not get submitted for marking, and those I can help you with. If you call me, we could work through them together. But the key questions you're on your own. You have to do those on your own, and those are the only ones that you need to submit to be marked. So keep that in mind. And key question will be spread throughout each of the lessons. So again, support questions, as I said, do not submit for marking, but you do need to submit the key questions. Um, so it's best to write everything that you do. So I'm looking for solutions, not answers. So the answer is just what you get at the end of the solution. Just show me all of the steps that you use to get to your answer, okay, if you want full marks, okay? So it's best to, you're going to be using line paper and graph paper to complete the key questions. So label them at the top with your name and then the lesson number and the key question that you're working on, uh, so that when you either fax them out or scan them, it's probably best to scan and email them to me. And if you do it that way, I can mark them usually within a day and get them back to you so you get pretty quick feedback. And then that way, if you're making any mistakes, we could catch them early and set you on the right path. So keep that in mind. Scanning is best, and then I can mark, scan, and send back, and you'll get your feedback within a day or two. So again, getting help. My name again is Marvin Osman. My email address is there and my phone number as well. There are other people who have taught this course, and there may be some YouTube videos that you can access as well. I'm not a techie, not my forte, but if you contact the office, and there's a 1-800 number that was right on the, so I scroll back up here, you can see there's a 1-807 number and a 1-800 number. That's the fax number. So there's a number that you can call if you want to get access to the YouTube videos. Each lesson that I teach as well, each day will be recorded, and then these lessons will also be placed on Facebook, sorry, not Facebook, on YouTube, and then you can access them at a later date as well. So if you're not able to attend today's class, you can always go back and view it later. Or if you did or are attending today's class and you're not quite sure about something, you want to go back and rewatch the video, then you can go to the YouTube channel and you can do that as well. So keep that in mind. Um, when I do the lessons, and you'll see it as I get into it today, I will be adding information to the package that was sent to you. So, like I said, there are lessons that outline and go into detail on certain topics, and then I might add some new information. And then I will also be working through some examples that are not in the package that was sent to you. So the package that was sent to you, or that you may have, has examples, and the solutions are included in or with the example. So I'm not going to read those to you. I mean, they're there. You can read those on your own. So I will do additional examples so that you'll have more information or examples that you can refer to when you are working on the support and key questions. So the course is, like I said, it's going to be 20 lessons, key questions in each lesson that you'll have to submit. And then at the end of the course, there will be a final exam. So 70% of the course will come from the key questions, and then the exam will be 30% of your final mark. As I said earlier, there are 4 units, and each unit is broken into 5 lessons. So there are a total of 20 lessons, and we are going to be running the course for 9 weeks. So 9 times 4 classes per week is 36 classes. But yesterday was Labor Day, and there's a holiday in in October, which is Thanksgiving Day. So we're going to miss 2 Mondays. So we're going to have 34 classes to complete 20 lessons. So we won't have to do a full lesson per day um, to get through the course. So there's ample time. Some of the lessons are longer than others. Some are really short and some are much longer, depending on the topic. Okay, so again, there's your final mark. 70% for key questions, 30% for the final exam. There's also learning skills. So they will be graded on excellent, good, satisfactory, or needs improvement. Scroll down here. So the learning skills are listed there. I'm not going to go through all of these with you. Just the headings: responsibility, organization, independent work, collaboration, initiative, self-regulation. So those are the skills, learning skills that uh, will have to be marked or commented on when the report card is done at the end of the course. So you can read through what it means to be responsible, what it means to be organized, and so on. Word problems. So one of the things with word problems, uh, sometimes people have difficulty with them. So it's important that you read the question sometimes several times to make sure you understand what the question is asking you to do. So what does it want? What is it asking you to do? And then what are you given or what do you know? So you'll have to read through the question and write down the information that you know, what you are given, and then based on that, you will have to devise a plan to solve the problem, where it might involve using an equation or a formula. It may involve graphing something to find a solution. So there's various ways to come to a solution. The important part when you are working with word problems is that when you do find the solution, then you should write a statement at the end of your solution that answers the question. So, for example, what did you do yesterday afternoon? And then the statement at the end might read, yesterday afternoon, I went for a walk. So I answered the question with a statement. Now, this one is fairly straightforward. We're going to be looking at problems that involve calculations and numbers and so on. So we're going to look at not more complicated, but going to be using numbers and words. Okay, some tips. Again, try to get your key questions done as quickly as you can. I mean, don't rush, but don't procrastinate and put things off. And get them to me as soon as you can. When we're talking about rounding numbers as well, sometimes people have problems with rounding numbers. So rounding is especially important when we're talking about money. So when we're rounding money, what you need to do is, so for example, rounding to the nearest penny, which means two numbers after the decimal or two numbers to the right of the decimal place. What we need to do to round it off, we need to look at that third number, the number that comes to the right of the, for example, 1.23. I would need to look at the number that's to the right of the 3 to see if that number is 5 or bigger. So the example that's here, we do some calculations and we multiply by 1.13, for example, to figure out what the cost would be with taxes included. And sometime when you multiply by 1.13, you'll get a number something like this, 5.347890. Well, we don't need all of those numbers because dollars and cents, since we only need two numbers after the decimal or to the right. So all of the rest of the numbers need to go, not required. So what we need to do to get rid of those numbers, though, is decide, is 3.347, so 0.347890, somewhere between 34 and 35. Is it closer to 34 or is it closer to 35? So what we need to do is, okay, the 7. So if the number to the right is 5 or more, we add 1 to the penny column. So instead of $5.34, it becomes $5.35. So we round that to 5.35. The 7 is bigger than 5, or 5 or bigger, so we go up 1. The next example, we're looking at 2.9347187. So the number that's in the third place after the decimal, so to the right of the 93. So 93.47, so on, is somewhere between 93 and 94. Which one is it closer to? 93 is it closer to 94? Well, 4, that's in that third position, is less than 5. So if it's less than 5, we leave it as 2.93 or $2.93. So keep that in mind when rounding numbers. Now, if we're rounding to 3 or 4 or 5 decimal places, the same rule applies. Look at the number to the right of the number we're trying to round. 5 or bigger, we add 1. Less than 5, we leave it as it is. Then we don't need to do anything else. So if you need help, please feel free to, now it says by Facebook, I don't use Facebook, so by email or phone. I'll just make that correction here. I'll save that. So that's it for the study guide. I know it's a little bit dry, but we had to get through it. So now we're going to jump into the course. So I'm going to go over to my Microsoft Word, and this is the first unit, and the first unit is begins with lesson one, which is transformations of quadratic equations. So this is a fairly heavy topic. I wouldn't say it's complicated, but there's a lot of things happening in this particular unit. So it's important that we go fairly slow, and I will go fairly slow through this to make sure that you are understanding. And if you are on air, feel free to interrupt me at any time and say, can you repeat something? Can you redo something? Or whatever you want to. If you just want to chat, feel free to interrupt and say, let's chat, or I have a question. So I'm going to change my view to make it a page width. Okay. So I can minimize that and then maybe make it a bit bigger. Let's try that. Okay. So there we go. So unit one is going to be transformation. So transformation means we're going to be moving something. So again, there is my email address and my phone number. And so we're going to be looking at, this is called the vertex form of the equation. So for if you're not quite sure what we mean by quadratic equations, a quadratic equation is an equation when graph forms a parabola. And a parabola is a U-shaped curve that either opens up or opens downward. And we're going to look at some examples of that in a second. So what I would suggest to you as well when we're doing this particular unit is to have access to desmos.com. So I'm going to switch back to here and I'm going to click here. And here you can see this is a website. You can see it at the top, desmos.com. Desmos.com. It's free to use. It doesn't require any personal information to be entered. And this is one of the best ones that I've seen. I've used graphing calculators in the past to do this, but the windows are very small, like inch and a half square. So this gives you the full screen to work with. So we're going to be moving back and forth. I'll switch back and forth as we work through this particular lesson. So now I'm going to go back to my lesson. So before we begin, now you'll see that lesson one is actually, I should call it lesson one because lesson one is what the lesson is titled. So I'm going to call this class one. This will be today's class, class one. So before we begin, we're going to look at the most basic quadratic equation, which is y equals x squared. So whenever you see x to the power 2, or we say x squared, whenever you see an x squared term, that will automatically mean that the graph you're going to get is going to be a parabola. And we'll work through how to graph that now. And if you've forgotten what a parabola looks like, we'll work through it. So if you had like y equals x with no powers involved, then the graph would always be a straight line. So if you have a y and an x and other numbers could be tossed in there as well, then you're going to end up with a straight line. But if you have an x squared term, then you're going to end up with a parabola. So when we graph an equation, most times we start with the basics and we use a table of values. So a table of values allows you to pick your x values and then we'll solve the equation to find what the y values would be. So typically in quadratics, we start with, so I'm going to pick -5, -4, -3, -2, -1, 0, 1, 2, 3, 4, and 5. So if x is -5, and I substitute that into the equation y equals x squared, -5 squared, so any number squared, so a number squared means a number multiplied by itself, or a number times itself. So a -5 squared means a -5 times a -5. When we multiply two numbers that are negative, the result will be positive. So -5 times a -5 is positive 25. So as you can see, any material that's in blue that you can see on the screen is material that's not included in your package. It's material that I've added to help augment the course. So help give you more examples, and maybe more information is included in the package, and hopefully help you be more successful. So I'm going to work down through now. So a -4 squared, or -4 times a -4, is a positive 16. A -3 squared is a -3 times a -3, which is a positive 9. -2 squared is -2 times -2, which is a positive 4. And -1 squared is a -1 times a -1, which is a positive 1. 0 times 0 is 0. 1 times 1 is 1. 2 squared, 2 times 2 is 4. 3 squared is 3 times 3, which is 9. 4 squared is 4 times 4, which is 16. And 5 squared is 5 times 5, which is 25. So you notice the part that's in red is the part that we're doing online today. So these are the solution. So the red is the solution to the problem. So this is sample problem 1.1. So the red is the solution. So the next part of this is we have a table of values. So we are going to graph y equals x squared using Desmos. So I'm going to go over to Desmos. So go to here. Now, when I switch screens, Jonathan, I'm just going to see if I can see you here now. When I switch screens, so for example, I've switched now to Desmos. Does it automatically switch, or do I have to reshare? Can you see my Desmos screen right now, Jonathan? So I'm not sure if what I'm sharing, or if I need to stop sharing my the lesson itself and then share my new window, which would be my window here. Okay, I'm not quite sure. So we're going to have to iron out some bugs today. What I'll do at the end of today's class is I'll touch base with the tech people in the studio to see, because I'm guessing that you might not see. It says I'm sharing my screen, but I'm not quite sure when I switch. I'm just going to take a break for a second. I'm going to check with my wife who teaches at WASA and ask her if she can give me a hand. Bear with me for just a second. Actually, okay. Okay, I'm back. Problem solved. Yeah, so apparently you are able to see it. So to graph y equals x squared, all you need to do is to go up into this little box right here and type in, using your keyboard, y equals x, and then to square a number or to exponent 2, if you look at the number 6 on your keyboard, and there's a little thing, it's called a caret, but it looks like a roof of a house, like an upside down V. If you go shift number 6 and then type in 2, that will square the number for you. So now you can see y equals x squared, and then you can see that in that little blue box to the left of the equation, there's a red dot with a squiggly line that goes through it. If you look at the graph to the right, you can actually see the graph. So that's what y equals x squared looks like. Now, if you think about the table of values that we just created, we had -5 and, oops, whoa, moved too quickly. -5, let's see if we get -5 here. I'm just going to pull the graph down. -5 is 25, and then I'll just -4, 16, -3 and 9, -2 and 4, -1, 1, 0, 0, 1, 1, 2, 4, 3, 9, 4, 16, and 5, 25. This point down here, 0, 0, that right there, I just put a little dot on there, that is called the vertex. Okay, and the vertex is the point where the graph changes direction. So if you were to start on the left-hand side of the graph, let's say I put my cursor up here, and I were to follow on the line, I'm going down, 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 and I get to 0, 0, and then once I go to the right of 0, 0, I go up, 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 and I keep going up. So this graph opens upward, and it goes on to infinity. It keeps going on forever and ever in that same direction. It will never turn and come back down. It will always keep going up in that direction. Jonathan, you have a question? Is it showing the graph now, Jonathan? Okay, so for some reason, so I'm going to have to, I'm not sure. I think what I might have to do is go into where it says share. And can you share? Okay, so I see chats there too. Remember, screen sharing doesn't show. Shows pause. Okay, so we're gonna fix this. So where it says your screen sharing is paused, I'm not sure why it says that. Because I didn't pause it. Video is on. I should actually turn my video off. Oops. So you don't need to see me. Audio is on. So if I click on stop share, hopefully it didn't end the session. Okay, so now I want to go to this one here and then come down to Zoom. Okay, there's my zoom again right here. And now I'm going to maximize this and go to, where is my Word gone again now? Go to Microsoft Word and come, so whenever I go up, this is weird. I can't share right from my Word document. I got to go back into here, and share. And I want to share. I don't see it on the screen right now. Where is, I don't see Desmo's there to share. So I can see I'm back into my lesson again, but I want to get to desmos.com. So Jonathan, I'm assuming you're seeing right now where it says sample problem number 1, create a table of values. We're back to there now. All good. I can see Word. Okay, yeah. So what I want to do though is I want to stop sharing this, and I want to share my desmos.com window. So for some reason, if I just switch over now, see if that works. So here, oops, go to, nope, that's not what I want. I want, that's not what I want either. Okay, I got to go back into here and go to, oops, get out of the way here. Desmos.com. That's what I want to see on the screen. So, can you see it now, Jonathan? Can you see my desmos.com or Desmos window? Okay. So for some reason, I'm just going to pause for a second and try to get this figured out before I move on. So I'm gonna mute myself right now. Jonathan, if you can play some music or something until I get back, and then once I get back, I'll let you know, and then we can move forward.
Tear out the walls. I have accountants pay for it all. They say I'm crazy, but I have a good time. I'm just looking for clues at the scene of the crime.
Okay, I'm back. There was an issue, there is an issue with switching between the two different programs and using Zoom. It doesn't like us to do that. So what I'm going to have to do is take my time, and we're going to have to go slowly, and then I may have to exit this and then open the other one, but we'll work through it. So anyway, here is the equation, y equals x squared graphed. And again, a parabola is a U-shaped curve that opens up or opens down. This one opens upward. It will continue to open upward forever to infinity, and it will never turn and come back down. Okay, so that's what a parabola is. At the very bottom, like I said earlier, I'll put it in there again, the point 0, comma 0, okay, that is the vertex. So the vertex, by definition, is the point where the graph changes direction. Okay. So it's the bottom of the U. If it's like this, if it was inverted, it was opening downward, it'd be the very top. So it's the very top or the very bottom of the graph. And we're going to look at many different examples. So you'll get to see lots of examples. As I said earlier, I'm just going to make this a bit wider. So, okay. So we looked at, if I point, that's the point 1, comma 1, 2, comma 4, and so on. So those are the values that we calculated in the table of values. So this is the very basic or most basic quadratic equation. So a transformation means we are going to take what you see on screen right now, and we are going to move it, stretch it, squat, squish it, whatever you want to call it. We're gonna do things to this particular graph, and when we get into an equation, we're going to look at it shortly. Certain numbers do certain things to the graph. So, for example, one number, if it was positive, will make the graph open upward. If it's negative, it will open downward, and we'll go into those when we switch back over. So this, again, keep this in mind. This is the most basic equation, and this is when everything else will be compared to. Okay, so I'm going to click on stop sharing this, and I'm going to open my Word document, and I'm going to have to go back into, I got to remember to do this all the time, or we might have issues. So I'm going to go back into, I don't want to go back into Desmos, go back into Microsoft Word, and I'm going to share this. Okay. So at some point, what I might try to do is to have both the Microsoft Word and Desmos on screen at the same time. I'll play with it tonight and tomorrow to see if I can do that. And if I can do that, then that will save us some time and effort of switching back and forth. So again, y equals x squared. These numbers produce that graph that we just looked at. Okay. So most basic one. So now we're going to look at what we call the vertex form of a quadratic equation. And we use letters to represent the numbers. So y equals a bracket x minus h bracket. So when you have a number outside of a bracket, it means we are multiplying. X minus h squared plus k. So whenever we graph an equation, we only need a y value and an x value. The a and the h and the k will actually be numbers, but those numbers represent different things. So that's why we use the letters a, h, and k. So the a value is the number that comes very first. Right after the equal sign, there will be a number. and that number is the A value. And what that number represents or tells us is in which direction the parabola is going to open. If that number is positive, the parabola opens upward. If the number is negative, it opens downward. Now, in this particular equation, we looked at y equals x squared. Even though there's no number in front of the x squared, it's understood to be a 1. So this means y equals 1x squared. We don't write the number 1 in equations. So it'd be like saying, uh, what did you have for lunch? I had an apple. You don't say I had one apple for lunch. You said I had an apple. And it's understood that when you say that you had an apple for lunch, then I know you had one apple. Because if you had two apples, you would have said I had two apples. So same thing when we're looking at equations. If there's no number in front of the letter, the variable is called. If there's no number in front of it, it's understood to be 1. So keep that in mind. So in this case here, that number 1, there's no negative sign. And likewise in mathematics, when we're talking about positive numbers, we don't say positive. It's just understood to be positive. So for example, if we look at temperature, if I ask you what the temperature is today and you said it is 15 degrees outside right now, you didn't say it's plus 15 degrees right now or it's a positive 15 degrees right now. You said it's 15 degrees Celsius. I know 15 degrees is positive or 15 above zero. If it were cold and it were 15 below zero, then you would say 15 below or it's a negative 15. So there'd be a negative sign in front of that 15. So positives, we don't write positives. So in the table of values, we had minus 5, minus 4, minus 3, minus 2, minus 1 in the x column. But when we did the 1, 2, 3, 4, 5, we didn't put the positive symbol in front of the 1, 2, 3, 4, 5. It's understood that they are positive. Okay, so keep that in mind as we're going through this. So why the A is tells us which way the parabola opens, up or down. There are two other numbers or values. So here's an example on the next page where the A value is positive, so the parabola opens upward. And the next example shows where the parabola opens downward. That's what it looks like. So it's an inverted. So these two would be basically mirror images of one another. One opens up, this one opens down. And if it opens down, then the A value will be negative. So technical issues today, so I apologize for that. And hopefully by tomorrow we've got everything ironed out. I'm not going to go any further because I don't think we're going to have time to get through the next example today. So we'll pick up from here tomorrow, and then hopefully things will run more smoothly. So Jonathan, that's it for me for today. I'll probably reach out to Tom tomorrow or yourself and